All right, guys. Hey, everyone. Mr. Fortin here. I got to admit, I'm a little frustrated right now. I just spent about 20 minutes explaining all of the classroom exercises, going through the whole darn thing, explaining how you can use your triangle similarity shortcuts document here to help you on problems like these. Spent 20 minutes filming it, and then it just didn't work. Like, there was still me in the video. Like, you can see me and you could hear me, but you couldn't show the work. So I'm just going to try to show the work that I did. Hopefully you can watch this quickly, get a sense of how to do these problems. If not, ask me questions and try to get caught up come Monday. But anyways, just to summarize again what we did in class, like last section, the section before, I mean, section 5.4, AA similarity postulate, okay? The way we want to organize ourselves in terms of remembering the triangle similarity shortcuts is that it comes from AA, that's when we have two pairs of congruent angles between one triangle to another triangle. That's enough to deduce that the triangles, well, they got to be similar to one another, right? We observe that. It's a postulate, SAA similarity postulate. Angle C, congruent to angle F. Angle E, congruent to angle E. B to angle E. That's enough to prove by AA similarity postulate, okay? If I don't have two angles that are congruent from one triangle to another triangle, what if I only got one? Okay, if I only got one right here, angle B congruent to angle E, and that's all I have. Well, I need a little bit more criteria. What I would need is I would need the included sides, okay? Remember, the included sides are the sides that touch the angle itself, not the side that's opposite. This is opposite that angle. Okay, the included sides need to be in proportion, okay? So if I knew that angle B was congruent to angle E, well then BC, right? BC is an included side. It corresponds to this one. It's a little bit longer over here, right? Longer over here than this, longer over here than that. So that means EF, okay? EF, okay? That would be my scale factor from this triangle to this triangle. And as long as the scale factor is the same between the sides, then I would know I'd have the included sides in proportion, okay? BA to ED. Look, I have B, right? B is the congruent angle. I got B in both the numerators. I got E in both denominators, so yes. If this proportion is true, then I know included sides are in proportion. I can use the SAS similarity theorem, okay? Two pairs of angles congruent between two different triangles, AA similarity postulate. One pair of angles and included sides in proportion, well, that's enough to deduce those triangles need to be similar by SAS similarity theorem, right? So similarity theorem, it's not a congruency postulate. Anyways, because we did it last semester. All right, and then we organize it. Two pairs, one pair. What if we don't have any pairs of angles congruent between the two different triangles? Can we still deduce that triangles are similar to one another? Well, I explained the proof of the SAS similarity theorem. I did a great third block. Oh man, that was a great justification. Like 3 minutes. Second block, I got to kind of turn around. Anyways, if I had time, yes, I'd be able to prove it to you, right? It's kind of the proof's the same thing in ways about the SS similarity theorem. If I have no pairs of congruent angles, okay, I got to show all. I got to show all those sides, all three. And how many sides are there in the triangle? There's three. I got to show all three of the sides of this triangle is in the same ratio with their corresponding sides in the other triangle, okay? So that's why we have an extended proportion here, okay? BC to EF is the scale factor, so the scale factor needs to match amongst all the sides, okay? That's what we call the SSS similarity theorem, because all the sides, side one to side one, side two to side two, side three to side three would all be in the same ratio and maintain that scale factor, okay? And we'd say they're similar, okay? BC to EF, BA to ED, AC to DF, okay? We know that those ratios are the same. Well, we can assume that they're similar, okay? We're not assuming, we know by theorem that they're similar, okay? And then we can use definition of similar afterwards and say that these angles are all congruent if we wanted to, right? If we wanted to use that in our justifications of something else, okay? All right, anyways, here are all the answers to the classroom exercises. I'm sorry, I'm not gonna go through them all again with you. I don't wanna film another 20-minute video. I'm gonna keep this one more about 6 or 7 minutes or so, okay? But here are my answers, okay? Here, if I can peep getting one pairs of angles congruent, I'm looking at my sheet here. Well, when I know one pair of angles congruent, well, I can't get a second pair, so it's not AA. It's probably not SSS. It's probably the SAS similarity theorem because I have one pair of angles congruent, and I just need to see, can I get my included sides in proportion? And yes, for this one, I can, okay? I got my included sides kind of highlighted here, right? Those are the sides that are touching the two congruent angles. Vertical angles are congruent, first of all. I got congruent angles. So now I need to look at here, okay, going to this acute angle here, I got a 12 side, okay? Going to this acute angle, I got a 9 side. I always like going small to big, all right? I'm just used to seeing fractions where the number on top is lower than the number on the bottom. That's the way I'm used to, okay? So 9 to 12, okay, 9 to 12 right here would be in the same ratio as small to big. Okay, notice here I got my obtuse angle there, I got my obtuse angle there. So these are in corresponding positions. 6 to 8, yes, those would equal each other. Okay, divide 6 and 8 both by 3. I get 2. Sorry, by 2, I get 3 to 4. By these each by 3, I get 3 to 4, right? 12 divided by 3 is 4. So they're both in a 3 to 4 ratio. My included sides are in proportion, and I got that congruent angle. Yes, here it is. I got the SAS inequality, right? So these two triangles congruent by SAS inequality. What I have here in green for all these is you have to state the similarity, okay? So this is where you have to go through when you're doing problems like these and making sure the corresponding vertices are in order, okay? So I know I can see it, I can feel it. I proved it here with my proportion and my congruent angles that I have similar triangles. Now I need to go through my vertices to make sure they align. Triangle, I think this is meant to be an O, right? I think I started with O. Just start with this here. I know that O is going to be congruent to itself. So I started with O there. I started with O here. And then went from O and I went to the acute angle, which is K, and then went down to the obtuse angle, which is T. So I would do that over here too as well. O, go to the acute angle, and down there the obtuse angle. And if you do it in the same order like that, you're going to write the similarity in a corresponding manner, which will be correct answer. You get more points, okay? So that one's SAS in similarity. Hopefully you see what you're doing on that one. This one here, this one was not similar. You're given angles. You're given nothing about sides, so I can't do anything about SAS or SS similarity. You're just given angle measurements. And this one here, if I do 60 plus 70, that's 130. 180, right, which is the whole triangle adds 180. If I subtract 130 from it, I get 50. Is that 50 degrees right there? No, it's 40 degrees, okay? There's no 40-degree angle in this triangle. So it can't be similar, right? Because all the corresponding angles need to be congruent. There's nothing that corresponds with that 40-degree angle. So this one's not similar, okay? This one's also not similar. This is actually kind of a harder one. I wish I had that 20-minute video so you'd see why this one is not similar, okay? I mark up my vertical angles. Okay, what's the problem with this one? Stop and think about it a second. I got my vertical angles, they're congruent. So I'm thinking SAS similarity theorem. SAS similarity theorem gets, well, that's got one pair of congruent angles. I have that. What else do I need? Well, I need the included sides in proportion, okay? So what I have here is I got one pair of included sides that is in a 1 to 2 ratio, 15 to 30, small to big, small to big, small to big, okay? I also have this, but wait, this is not an included side. 20 and 40 are not included. They're opposite the congruent angles, okay? So even though 20 to 40 is a 1 to 2 ratio, suppose they could be similar, okay, but I don't have enough to use SAS similarity theorem, okay? If I knew that this were 5, for instance, here, and this were 10, then that would be enough, okay? Because I'd have the other pair of included sides. Remember, included means what there are sides that form the angle, right? They include the angle if I put them together, okay? And the ones where they mark up this 40 side and this 20 side, they don't make up the angle. They're opposite the angle, okay? So this is no similarity, or not similar is what I wrote down here, okay? So it's wrote not similar. Or no similarity can be proven, okay? This one here is SSS similarity here, right? Your strategies, right? Stay organized. Start from like the smaller side, right? The smaller sides are always going to be the corresponding sides. You just need to see if I set up the ratio between the smaller sides and then the medium sides and the larger sides, if that scale factor is consistent amongst the three. If so, SSS. And this one it was 10 to 16. What's the next biggest side here? 15. So 15 to 24. Okay. 10 to 16 is 5 to 8. 15 to 24. Yeah, if I divide 15 by 3, I get 5. Right? 24 by 3, I get 8. So 5 to 8 ratio. 20 is the biggest side here to 30 again, small to big. Okay, but I'm looking at the largest sides now. 20 to 32. Yes, so divide both by 4, I get 5 to 8. Okay, so this one's a good example of the SSS similarity theorem, okay? My sides are in proportion. So if I don't specify how many that is, that means all my corresponding sides are in proportion, all three. That's what I needed for SSS, okay? And then I write my correspondence. Stay organized. I went with obtuse angle here. I chose that first. Then I went to the smaller, I used the smaller side, and then I went to the long side here, so it's HFG here. So that means I started my obtuse angle here, R, as I go from right to left. R, and then I go my smaller side here, which is gonna be X. Okay, why? Well, I went H to the smaller side here, F next, okay? So RX corresponds with HF, we're good to go. And then XS corresponds to FG. Yes, I've written my similarity statement correctly, okay? They're not just having you say the two freaking triangles are similar to one another. They want you to write it in a way that communicates which sides and which angles correspond to one another, okay? Number 5 here, if you did this one here, maybe you're checking your answers, they gave you the right angle there. Yeah, of course, a right angle means the lines are perpendicular. So all 4 of those angles at the perpendicular are gonna measure 90 degrees, okay? So this is 90 degrees, this is 90 degrees. Wow, okay? I got one pair of congruent angles in this left triangle here to this right triangle here. I also have 2 side lengths to play with. And here I proved those side lengths are indeed in proportion, okay? I went from the smaller triangle to the bigger triangle, and I went from the smallest side to the smallest side here. So 9 to 15, okay, is a 3-to-5 ratio. And then look, this 15 is also in the left triangle here, okay? It's a longer leg of this left-right triangle. And it's the, sorry, it's the longer leg of this right triangle. And it's shorter leg, right, of the left-right triangle. So anyways, shorter leg 9 to shorter leg 15, okay, is gonna be the same as longer leg 15 to longer leg 25. And yes, right, I have the angles, one pair of angles congruent, and now I have this as a 3-to-5 ratio, 3-to-5 ratio. Yeah, right, 9 divided by 3, 3. 15 divided by 3, 5. 15 divided by 5, 3. 25 divided by 5, 5, right? 3-to-5 ratio, okay? We're good to go. We have side lengths in proportion. And then the most important thing is that they're including the congruent angles. They make up here, right? This 9, this 15, I got what I need for the SAS, similarity theorem to be applied there. This one here, am I given any angles? No, I'm not given any angles here. So I'm not thinking AA, I'm not thinking SAS similarity. I'm thinking maybe this is SSS, and it was if you played with this here. Go small side to small side, medium side to medium side, large side to large side. Okay, look, the 24 is the largest side and the smallest guy, but the smallest side and the biggest guy. And it's fun. That's fun. Okay, so 16 to 24 is a 2-to-3 ratio. 20 to 30, very easy to see. The 20 to 30 is a 2-to-3 ratio. Okay, just divide both of them by 10, you get 2/3. Okay, 24 over 36, divide both by 12, you get 2/3. There we go. We've proven it. All sides are in proportion. SSS, similarity theorem, we can apply it, okay? So you guys will have problems like this on the written exercises, numbers 1 through 10. A lot of them are kind of like this here. And then you get into proofs. This sort of help you with the proofs a little bit here. Is that if you wanted to prove triangles similar by SSS, you got to show something like this. You got to show that first, okay? Remember, proofs, you need evidence for proofs. How am I going to get to similar triangles through SSS? If I knew this here, well, I would have to show that all pairs of sides are in proportion, all corresponding pairs of sides here. And RS corresponds to XY, they're the first 2 letters. ST, okay, to YZ, they're the second and third letters. First and third letters. TR goes to ZX, okay? So they said extended proportion there. You got to remember this from section 5.1. An extended proportion means 3 or more equal ratios, okay? So triangle, if all 3 of those equal ratios, they equal each other, you can use SSS similarity theorem to prove triangles are similar. And then, hey, you can use definition of similarity to rock out there and say angles are congruent after that. Okay, anyways, we got here number 8, SAS similarity theorem. If you know that angle R is congruent to angle X. Okay, so this one's here. I'm using SAS similarity theorem. I need to know one pair of angles are congruent, okay? They gave it to us here. So the question is, what is the included sides there? How do I say the included sides are in proportion? Well, it all goes through. My included sides would have the angle forming part of them. So I need RS here. I need RT here. Okay, again, they don't give you the diagram to this because they want you to pay attention to letters. Okay, angle R is motive of RS and RT, and it goes with angle X here. So RS, okay, has to be the same ratio to XY because we got to find the scale factor as RT, okay, right? Because RT is over here, forms angle R, and XZ. Okay, XZ there. Okay, so that's all you need to know for SAS. Okay, you get the pair of congruent angles. You don't need the extended proportion. Ooh, it got dark again. You just need the included sides to be in proportion, then you're good to go. Okay. All right. Thank you guys for watching. I hope this video worked. I hope it helped a little bit. I'm sorry I couldn't do the whole thing with you together, but I spent 20 minutes filming it and I don't want to redo the whole thing again. So I'm filming this. Hopefully it worked out. Hopefully it helps you out in the homework tonight. Have your kind of little sheets handy to work through it when you're giving justification about why things are similar. This could help you. 2 pairs of angles. Okay. Similarity, asimilarity. 1 pair of angles, okay, well, maybe it's SAS similarity. No pairs of angles, well, we're gonna have to look into SSS similarity. Thanks for watching, guys. Have a great weekend. I will see you guys on Monday. Message me if you have any questions. Bye.